So good morning to one and all. Good afternoon to one and all. Today I am here to give the brief introduction about the operating system. Operating system that act as an intermediary between the users of the computer and the computer hardware. The operating system goals are executing the user programs and make the solving user problems easier, make the computer system convenient to use the computer hardware in an efficient manner. Then computer system structure. Computer system can be divided into the four components that are hardware, operating system, application programs, and users. So first of all, what is an hardware? Hardware provides the basic computing resources. The hardware includes maybe the CPU, memory, IO devices, input output devices, etc. Then operating system. Operating system controls and coordinates the use of the hardware among the various applications and the users. Application programs defines the way in which the system resources are used to solve the computing problems of the users. Word processors, compilers, web browsers, database system, video games, etc. are the application program. Users are nothing but the people, machines, other computers are the users of the computer. So here four components of the computer system are given: user 1, user 2, user 3, user 4 up to user n. Below to that, user, compiler, assembler, text editor, database system. All these are inside the system and application programs. Then below to that, operating system layer is there, and below to operating system, computer hardware is there. So OS is a resource allocator. It manages all the resources, decides between the conflicting requests for an efficient and fair resources use. OS is a control program that controls the execution of the programs to prevent the errors and improper use of the computer. OS is a resource allocator, manages all the resources, decides between the conflicting request for the efficient and fair resources use. OS it is a control program, control execution of the programs to prevent the errors and improper use of the computer. No universally accepted definition. The one program running at all times on the computer is the kernel. Everything else is either a system programs or an application programs. So here, everything else either a system program ships with the operating system or an application program. Then computer system organization, computer system operation. One or more CPUs device controllers connects through the common bus, providing the access to the shared memory. Concurrent execution of the CPUs and devices competing for the memory cycles. So here you will see that a common bus it is connected to the memory, and to the common bus CPU, disk controller, USB controller, graphics adapter, all these devices are connected. Again to these devices, USB controller, mouse, keyboard, printer, all these are attached. Graphics adapter are attached to the monitor. Then disk controller are attached to the hard disk. So it allows the concurrent execution of the CPU and devices of the computing for the memory cycles. Computer system organization. IO devices and the CPU can execute the concurrently. Each device controller is the in charge for particular device type. Each device controller has a local buffer. CPU moves the data from or to the main memory, or to or from local buffers. IO is from the device to local buffer or the controller. Device controller informs the CPU that it has finished its operation by causing the interrupt. Now next one it is bootstrap it is a program loaded at power up or reboot, typically stored in rom or eprom, generally known as the firmware. Initializes all aspects of the system including the CPU, register, device controllers, and the memory contents. Locates and loads the operating system kernel and starts the execution of the first process, such as init process, and waits for the event to occur. Common functions of the interrupts. Interrupts transfer the control to the interrupt service routine, generally through the interrupt vector, which contains the addresses of all the service routines. The interrupt architecture must save the address of the interrupted instructions. Incoming interrupts नंतर काय are disables. Incoming interrupts are disables नंतर काय while another interrupt is being processed to prevent a lost interrupt. A trap is a software generated interrupt caused either by an error such as divide by zero error or a user request system call. An operating system is a interrupt driven. Interrupt handling. The operating system preserves the state of the CPU by storing the registers and the program counter. Separate segments of the code determine what actions to be taken for each type of the interrupt. Here, this is the interrupt vector table. The interrupt number provides an index into the table. Functions for each interrupt handler it is given. ISR, that is interrupt service routine vector table. Main program flow, interrupt service routine ISR. Interrupt processing. The interrupt along with their associated interrupt service routines are stored in an interrupt vector table. Start interrupt signal detected. Then save the variables and registers and the look up ISR address in the interrupt vector table. Place the ISR interrupt service routine address in PC branch to ISR. Then restore save register and variables and the branch to top of the page to decode and execute cycles. It is use the start perform the work specific to the interrupt. It will return and restore the saved register. Then input output structure. After the input output starts, control return to the user program without waiting for an IO completion. System call request to the operating system to allow the user to wait for the IO completion. Device status table. It contains the entry for each IO input output device indicating its type, address and state. Operating system indexes into the input output devices table to determine device status and to modify the table entry to the include the interrupt. Direct memory access structure. The use direct memory the use for high speed IO devices able to transmit the information at the close to the memory speeds. Device controllers transfer blocks of the data from the buffer storage directly to the main memory without CPU intervention. Only one interrupt is generated per block rather than one interrupt per byte, etc. Here storage structure, main memory programs, storage structure only large storage media that the CPU can access directly. Programs and data cannot reside in the main memory permanently because main memory it is limited to store all the programs and data permanently. Main memory is volatile. Main memory is volatile, so secondary storage is provided extension of the main memory that provides a large non-volatile storage capacity. Magnetic disk, rigid metal or a glass platters and they are covered with the magnetic recording material, etc. So this surface it is logically divided into the tracks which are subdivided into the sectors. So this controller determines the logical interaction between the device and the computer. So next it is storage hierarchy. The storage system organized in hierarchy by speed, cost and volatility. The higher the level in the hierarchy are expensive but fast. As we move down the hierarchy, the cost per bit generally decreases whereas the access time generally increases. Caching, copying the information into the faster storage memory. The main memory can be viewed as a last cache for the secondary storage. Here the secondary storage device hierarchy it is given at the bottom. Magnetic tapes are there. Above to that optical disc, above to that magnetic disc, then electronic disc, main memory, cache and register. This is the storage hierarchy. In this way the computer memory stores the information. Then caching important principle of caching perform at many levels in the computer, that is in the hardware, operating system, software information. It is in the use copied from the store to the faster storage temporarily. Faster storage check the first to determine the if the memory is there. If it is there, information used directly from the cache. If not, data is copied, data copied to the cache and it is used there. So cache smaller than the storage being cache management, important design problems and the cache size and the replacement policies. This is how a modern computer works. This is a thread execution, input output, request, then data, then here it is interrupt, then data movement, instruction execution cycle, instruction and data memory. Fetch, decode, and execution cycle. Here, fetch, decode, and execute cycle and store structure. These are the each every instruction cycle has these four steps. That is fetch, decode, and execute and store. So this is the fetch, decode, and execute cycle. This diagram shows the diagrammatic representation of fetch, decode, and execute cycle. So here, fetch, decode cycle. So this is a multi-processing architecture. This is CPU 0, CPU 1, CPU 2. All CPUs are connected to the memory. That is the memory. It is shared between the multiple CPUs, and the CPU consists register and cache. So here the dual core design are there. CPU core 0, register cache, CPU core 1 and cache. They are directly connected to the memory. Distributed system. Now, what is exactly the distributed system? Computation and is distributed among the several processors. In contrast to the tightly coupled system, the processor do not share a clock or memory. Each has its own local memory. Communication is via through the network. These systems are termed loosely coupled or distributed system. The processor vary in size and the function and are called as the nodes. Advantages of the distributed system are reliability, then computation speed, then resource sharing and communication. These are the advantages of the distributed operating system. Next one, it is the cluster system. Cluster system are a form of distributed system composed of two or more independent machines coupled together, usually sharing storage via a sharing area network, that is SAN. Storage area network, that is SAN, provides a high availability service which survives the failures. Asymmetric clustering has one machine नंतर काय in hot standby mode while other machines or servers run the applications. The hot standby machine नंतर काय only monitors the active server. If it fails, the hot standby machine becomes नंतर काय the active server. So symmetric clustering has multiple nodes नंतर काय running application monitoring each other. So some cluster नंतर काय are for high performance computing. Application must be written to use in parallelization. So cluster system, an example नंतर काय is a view of cluster where the cluster master नंतर काय node does the management and provisioning and the set of the compute nodes नंतर काय that do computations. So here Beowulf clusters नंतर काय are scalable performance clusters नंतर काय based on commodity hardware on a private network नंतर काय with a open source software, that is Linux infrastructure. Each consists of a cluster नंतर काय of a PC or workstation dedicated to running the high performance computing task. Multi-programming needed नंतर काय for efficiency. Single user cannot keep the CPU and IO devices busy all times. नंतर काय multi-programming organizes the job so that the CPU always has one to execute. A subset of total jobs in the system is kept in the memory. One job is selected and run via job scheduling. When it has to wait, OS switches to the another job. So here multi-programming keeps the CPU always busy in such a way that one job at least he that operating system must execute. Then time sharing operating system. Time sharing it operating system, it is also called as multitasking operating system, which is a logical extension in which the CPU switches the jobs so frequently that the users can interact with each job while it is in running state, creating the interactive computing. Response time should be less than 1 second. Each user has at least one program executing in the memory. Processes if the several jobs ready to run at the same time, CPU scheduling is there. So if process don't fit in the memory, swapping moves them in and out to run. Virtual memory allows the execution of the processes not completely in the memory. So this is the memory layout for multi-program system. In operating system, number of jobs like job 1, job 2, job 3, job 4, number of jobs are stored and they are executing the task simultaneously. Then interrupt driven by the hardware. Software errors नंतर काय or the request creates the exception नंतर काय or the trap नंतर काय division by zero. Request for operating system service. Other process problems नंतर काय include the infinite loop process modifying नंतर काय each other नंतर काय or the operating system. Dual mode operation allows the OS to protect itself and other system components. The user mode and kernel mode are there. Mode bit provided by the hardware provides the ability to distinguish when system is running user code or kernel code. Some instruction designated as privilege only the executable in the kernel mode. System can changes the mode to the kernel. Return from the call resets its the user. So this is the transition from the user mode to kernel mode. Timer to prevent the infinite loop. Processing hogging नंतर काय resources नंतर काय set interrupts after the specific period. Operating system decrements नंतर काय the counter when counter zero generates and interrupt setup नंतर काय before the scheduling processes to regain the control or terminate the programs that executes नंतर काय during the allocated time. Here the next one, it is process management. Process, it is a program in execution state, so it is a unit of a work within the system. Program is passive entity, process it is active entity. Processes needs the resources to accomplish its task: CPU, memory, IO files, initialization of the data. Process termination requires the reclaim of any reusable resources. Single threaded process has one program counter specifying the location of the next instruction to execute. Process executes instructions sequentially one at time until the completion. Multi-threaded processes नंतर काय has one program counter per thread. Typically the system has many processes नंतर काय some users, some operating system running concurrently नंतर काय on one or the more CPUs concurrently. Concurrency by multiplexing the CPUs among the processes or the threads. Process management activities. The operating system is responsible for the following activities in connection with the process management: creating and deleting नंतर काय both the user and the system processes, suspending and resuming the processes, providing the mechanism for process synchronization, providing the mechanism for process communication, providing the mechanism for deadlock handling. Okay, thank you.